Welcome to In 5 Minutes. The agenda of this clip is to implement the following expression in different styles of logic. We will be implementing it in static, dynamic, pseudo and Cmos, and also in C²Mos style. Okay, let's get started. The expression is y, which is nothing but my output, equal to d plus e plus a ANDed with b plus c. We have already seen in the previous clip the shortcut key of how to make a schematic or a circuit for a static logic. We'll hide the bar. Whatever is below the bar is nothing but my pull down network of my static logic. Here it's D plus E plus A, which clearly says that there are three transistors with input D, E and A respectively, and all these three transistors are connected in parallel, which in turn is connected in series to two transistors B and C, which are connected in parallel because this is nothing but plus again. So let's quickly draw this. Pull down comprises of NMOS. So this is D parallel to E parallel to A. This is in series with B, which is in turn parallel to C. And this is my ground. And this is where I'll take my output from. So this is nothing but my pull down network for my static logic, which clearly indicates the implementation of the expression by hiding the bar. Now let's go ahead and draw the pull-up network. We have also seen that the pull-up network will be exactly complementary to the pull-down network. What do we understand by that? It means that in the pull-down network, if my D, E and A are parallel, in my pull-up network they would be connected in series. And remember, now we would have PMOSes. So this is D in series with E in series with A. Now this entire three transistors in the pull-down network is connected in series. So in the pull-up network it will be connected in parallel, and they are connected in series to B parallel to C. So here it will be B in series with C. So B, C, and they are connected in parallel. This is nothing but my VDD, and in between my pull-up and my pull-down network is nothing but my output, Vout. So this is nothing but my pull-up network for my static logic. Now this is nothing but the static CMOS logic. We have already done the implementation. In case the bar was not present here in the expression, then we would have put double bar and simplified the expression using De Morgan's, as we have seen in the implementation of XOR and XNOR gate. Now let's quickly implement this using Pseudo and Cmos style. So we know that the Pseudo and Cmos style would have the same pull down network like we had for the static. So this pull down network for static is exactly the pull down network for Pseudo also. So this is the same circuit which will be drawn here, and it's grounded. Actually the ground is also present, so you don't need to draw it. This is just for understanding. And my pull up would be nothing but my PMOS transistor. So it won't be this, it will be just a PMOS transistor with its input gate grounded to 0. So this is my VDD, and output is taken in between the pull-up and the pull-down network. So this is nothing but my Pseudo and Cmos circuit for this particular expression. Let's quickly go ahead and draw the same or implement the same using dynamic style as well. Here we are going to do the dynamic style implementation. In dynamic style also, we have already seen that the pull-down of static needs to be drawn. Additionally, it will have another NMOS transistor, which is nothing but my footer transistor connected in series and closer to ground, and there will be a header transistor also, which is nothing but a PMOS, and both this PMOS and NMOS have their input shorted and it's given as phi. One terminal is connected to VDD, and in between, this is my total pull down network of dynamic logic. In between my pull up and my pull down network, I will have an output which is nothing but Vout, and this is nothing but the dynamic implementation of the given expression. To wind up, let's quickly implement this using C²Mos style. So in C²Mos style, we know that we'll have to draw the same pull up like we drew for static, and we'll have to draw the same pull down as we drew for static. This is VDD and this is ground. Already if you have drawn this exactly, VDD is also incorporated in that box, so you don't have to get confused. Or if you have just drawn the transistors, then VDD is present. Same is the case with ground. Here with the pull up, additionally there will be another PMOS, and with the pull down there will be an additional NMOS where this is phi and this is phi bar, and both of them are connected closer to the output. That means the output is taken in between these two additional transistors, and now this becomes my pull up for my C²Mos logic, and this becomes my pull down for my C²Mos logic circuit. So with that, we saw how to implement any given expression in different styles of logic. We have also seen that in case if we had to implement a domino circuit, what we would have done is, this is my dynamic. Remember, at the output of dynamic and C²Mos, there is always a capacitor. So here also there would be a capacitor, and if we had to do a domino style implementation, then this output should be connected to an inverter, which is nothing but a static inverter drawn here, which we have already seen in the previous clips. And this is nothing but, with blue now, it becomes domino style of implementation. So hope you have followed and understood how to make or how to simplify an expression and implement in different styles of logic. Stay tuned for further clips. Thank you very much.